Hello. Now we are going to look at triangles and quadrilaterals. So a triangle has three sides, a quadrilateral has four sides. We're dealing with straight-sided shapes, and we are going to look at their area and their perimeter. So we're going to start off with the area of a rectangle. Well, if we think about what we know about a rectangle, we're going to have parallel sides here and here. We have parallel sides here and here. They're going to be the same length. So this is going to be 3 centimeters because that side's 3 centimeters and the other parallel side will be the same as well. That would be 2 centimeters. And we know that the area of a rectangle is going to be the length multiplied by the width. But we're going to start out by looking at why we would say that. So if we have a length of 2 centimeters, what does that mean? It means we have 2 units going that way. The length of 3 centimeters means we have 3 of the same units going this way. So if we mark them in, what would our shape end up looking like? So these are our units marked in. All of these are the same lengths along. Well, if I wanted to describe the area of this shape, instead of marking my unit lengths, I'd need to be counting something that I could use to describe bits of area. In the same way as these are all equal bits of length, how could I describe a bit of area that I could then count up how many of those bits I've got to describe the area of the shape? Well, I need to start with a unit, something I'm going to count up in. So if I take my centimeter lengths and I created them, I dashed them out into a little square that was going to be a 1 by 1 square, I could say that that was going to be 1 unit of area. In the same way as this is 1 unit of length, I could take that as being 1 unit of area and then count that up to get my total area. So when I mark off my little boxes, I say, how many of them do I have? I have 1, 2, 3, 4, 5, 6. I get 2 rows of 3. So when I would be simplifying my life, instead of having to draw this picture, I can see that I end up with 3 boxes this way and 2 boxes this way because I have because I have 3 units and 2 units. So we simplify this and say that the area is just going to be 2 by 3. But what we're really doing is saying if we created our 1 centimeter square boxes to allow us to count up units of area, how many of those units of area, those little 1 by 1 boxes, would we end up with? It turns out that it's a very useful shorthand to say that we would just be able to multiply the lengths together. But really what we're doing is saying how many of those little boxes would we end up with? We'd end up with 6 of those centimeters squares. So this is 1 centimeter square, and we end up with 6 of them. And so we say the area is 6 centimeter squares. So how does the perimeter work for our rectangle? Well, that would just be the length plus the width plus the length plus the width. Just walking around the shape. So we'd start at a point on our shape, and we'd say we walked this far, and then this far, and then this far, and then this far to get back to where we started. That's all the perimeter means. That's all it will ever mean. So if we can tell ourselves that story of what the perimeter means, regardless of how complicated the shape gets, we're always going to be able to work out our perimeter by figuring out how we would walk around the shape. So we don't learn off a formula like this. We say, how do we get around the edge of this shape? And that's how we tell ourselves the story of how we get its perimeter. So when we add all of that up, we get a total of 10 centimeters. And that's a length. We've just counted how far we would go in our unit of length. If we look at this shape here, this is a right angle triangle. How would we work out its area? Well, we know the formula, or we may know the formula, is just half of the base times the perpendicular height. I'm going to write that in. So where is that coming from? Half the base times the perpendicular height. Well, a base is just going to be one of the sides of our triangle, so it can be any side of our triangle, but if we want to use one of our sides as a base, we need to know the perpendicular height. So perpendicular means at right angles, so at 90 degrees going away from that side. So if we look at 6 here, we'd say that it was the base if we went perpendicularly out away from it. This is a right angle, a perpendicular symbol, going right angled out away, and we go 8 units to the far corner. Or if we took 8 as our base, then perpendicularly out from that to the far corner would be 6. If we tried to take 10 as being our base, which would be perfectly reasonable, we would need to know the perpendicular distance, the right angle distance, this little blue distance here, going from the 10 centimeter or the 10 unit side out to the far corner. If we didn't know that, we wouldn't be able to get the area that way. So in this case, the most sensible one to pick would either be the 8 or the 6, and then we'd be able to use the other one as the perpendicular height away from that base. But where is this coming from? Well, if we take our shape that we're looking at now and trace it back to a shape that we had already dealt with, we can see that our right angle triangle is just half of a rectangle. And we just figured out how to get the area of the rectangle. And we can see that this triangle, this right angle triangle, is just half of that. So that's why we have half of a side times the perpendicular height away from that side. Because really what we're doing is drawing a rectangle around our triangle, and we know that it's going to be half of that area of the rectangle. And that's why we must be very careful that we have a perpendicular height, that we have to go at right angles out away from the base, just like we saw with the 10 unit side here. So when we do that, it probably makes most sense to take 6 as our base, and then 8 would be the perpendicular height. So if we take a base of 6, then the perpendicular height away from that base will be 8 units. So we would end up saying half of 6 by 8. So we would end up with 24 units squared. We don't know our units this time, but it would be unit length squared. The perimeter is just adding up the sides. So we'd have 10 plus 8 plus 6, and we end up with 24 units because we're just measuring a length. What about a parallelogram? So I have a parallelogram here. A rectangle is also a parallelogram, but it has 90-degree corners. This one does not, so we would call it a parallelogram more generally. Well, this is just made up of 2 triangles. So if we draw in a diagonal across here, we can see that this is just made up of 2 equal triangles, because we know that our parallel sides are equal in our parallelogram. So these 2 triangles are identical. So we just have 2 of our half the base times the perpendicular height. So the area just ends up being the base times the perpendicular height. But we must know the perpendicular height, because really, again, this comes from knowing the area of a rectangle. So if we wanted to use one of our sides as a base, we would need to know the perpendicular height away from that side. So if we look at our 10 unit side length here, we know that perpendicularly up away from that, that's what this is supposed to indicate, is going up 4 units. Whereas the diagonal here, we don't know the perpendicular distance to the far side, so we wouldn't be able to use that as our base, because we don't know the perpendicular height away from it. So we would only take our base as being 10, and our perpendicular height away from that base to the far side would be 4. So that would be 10 by 4 is going to be 40 units squared. And then the perimeter is going to be just adding up all the sides. So 5 plus 10 plus 5 plus 10. Again, I am walking around that shape, and I end up with a total of 30 units all the way around. What do I have to do here if I have 2 parallel sides but the other sides aren't parallel? Well, this is called a trapezoid or a trapezium, and it actually works exactly the same way as the parallelogram. We can just draw a diagonal across it. We can draw a diagonal across it in either direction, and we just end up with 2 triangles. But this time they're not identical triangles. This doesn't look like this, but they do have a base of 8, and the perpendicular height to the far corner is 6, and there's a base of 12, and the perpendicular height to the far corner is 6. So they have the same perpendicular height because they're going the same distance between our parallel lines at right angles. So what we can say is the area formula for this is going to be called A plus B all over 2 times the perpendicular height. A is one of the parallel sides, B is the other parallel side, and they're just the bases of the 2 triangles. This is just adding 2 triangles together in algebraic form. the areas, I should say, of two triangles in algebraic form. So we'd just be able to sub in there. 8 is one of our bases. 12 is the other of the parallel sides. And again, this triangle and this triangle. We know the base here because we know the perpendicular height away from that base. We get those two. And then the perpendicular height that is shared by both of them is 6. When we simplify that, we get 60 units squared. And the perimeter is just adding up all of our side lengths. What happens if we want to deal with a more complicated question like this? So this is a triangle, so we know we have half the base times the perpendicular height is going to give the area. We're told the area is 96. So if I get this question, I'd say, well, I know the area is half of a base, half of one of the sides times the perpendicular height. I know that that should be equal to 96. Now I know more because I've given the information I was given context. And now I want to find the height here, which is the perpendicular height away from which side? From the 24 centimeter side. So if I took 24 as my base, then the height I am looking for, the h I am looking for, would be the perpendicular height. So then I'd have a formula with only one unknown in it. If I sub that base in, I'd end up with a formula with only one unknown, and I know how to solve that. So what I do with more complicated questions like this is write down what they've told me and use it to simplify. Write down the formula, write down the area that I was told about, what it's equal to, write down any other information that I can see from my diagram or my story that I'm given, and I can get to my answer that way. The height ends up being 8 centimeters. Now what shape do I have here? Well, it's not given to me as clearly, but if I have a straight line here and I have 90 degrees here and 90 degrees here, these two sides have to be parallel. Well, if I have two sides that are parallel and the other ones aren't, then I have a trapezoid or a trapezium. And that means that I can say that the area is going to be, if I broke that into two triangles, it's going to be A plus B, the two bases, all over 2, multiplied by h. And I can just sub into that and simplify. So when I sub in and work all of that down, I get 200 meters squared. So again, these are just two triangles. If I drew in my diagonal here or the other way, and I'd be able to say, well, I have the bases are going to be the parallel sides and the perpendicular height is the height in between the parallel sides. What am I going to do with this parallelogram here if I want to find h? Well, I say, what do I know? I can see I have 18 and 16 and 12 and h. Well, if I look at the h side, what I'm looking for, that's the perpendicular height away from the 12 unit side, and then the 16 side has a perpendicular height away from it to the 18 length that's in green, because this length is the same length as this length. So the base perpendicular height, base perpendicular height. If I think about that and I think about parallelograms, I think about area. So the area of my parallelogram would be a base times a perpendicular height. So I look at the information that's given to me and I can write out how to simplify this. So if the base was 12, the height, the perpendicular height, would just be h. And if the base was 16, the perpendicular height would be 18. So I can write that in. So if both of these are base perpendicular height, base perpendicular height, they both describe the area of the same shape. So base times perpendicular height must equal base times perpendicular height. And now I have an equation in h that I can solve. When I work that down, dividing both sides by 12 to get 1h, I end up with h being 24 units. And that is how we can go from knowing the area of rectangles by counting up the sides of our 1 unit squares up to dealing with parallelograms and trapeziums. And that is what we need for now.